Okay, so let's talk about some post-processing. If you are using SphereMan, um, the setup, I mean, like the core project that I gave you, the side scroller one, post-processing will already be in there and will actually be in your scene already. So there should be a little post-processing game object in here. It should be set up. The camera is set up. All is well and good in the world. So, but if you have started a brand new project and you do not have post processing, especially if you started like an actually full brand new project, you won't even have post processing in your scene. So um, you're going to have to import that package. By default, Unity does not import that package. So you're going to have to go to Package Manager, go under Unity Registry, wait for it to load, and then you can just write post in here, or posts. And you'll have a post processing package. There'll be a download button and then an import button. Once that is done, import that. You'll have post process in your project. It won't do anything right off the bat, but you will have it. So let's set up post processing. It's a little different in every rendering engine, so or pipeline, I mean. Unity has three pipelines. They have the built-in one, which is what we're using by default. They have a lightweight or universal render pipeline. Sorry, they changed the name of it, and a high definition render pipeline. So post is set up differently across all three of those. So if you're using URP or HDRP for whatever reason, let me know. I can go over that as well. But right now, I'm just going to go over the built-in pipeline post-processing. So once that's in, you have a few things to set up. The first thing you need to do, I guess you could do this in any order, but you need a post-processing volume in your game or in your scene. So you're going to go to Game Object, you can go to 3D Objects, and you're going to create a post-processing volume. That's just going to make this wee little box in here for you. It's going to have a box collider on it by default and a post-processing volume on there. So now we have a volume to add post-processing to. To create post-processing or to start adding it, you need a profile. Profile is what holds all your post-processing. The cool thing about profiles is you can use them in multiple scenes. That's why they do a like the profile system. Uh, Before it was set up like per scene, so you'd have to kind of duplicate things. But this is nice. You have a profile. If you change the profile in any scene, it'll update it in all the scenes that are using it, kind of like a prefab. To make a profile, you just simply go into the volume and hit the new button. You could also make one in your project by right-clicking and going to create one, but I like just doing this one. This creates it into the root of whatever scene you're using. It'll make a folder for that scene, and then underscore profiles, and it will add the profiles in there. You can keep these wherever you like, but that's where it keeps it by default. Then you can start adding effects. Now that still won't actually do anything to your scene. It won't start having an effect on there. The next thing you need to do is set up your camera to accept post-processing. The reason we do this is sometimes you want, if you have different cameras in your scene, you switch to a different game mode, to a menu, to something like that, you may want different post-processing on that scene versus other scenes. So they allow you to kind of set this up per camera. So to do that, we need to set up a post-processing layer. That's what was on here before. So if you go in here, you type in post, go to add component, type in post, and add a post-processing or post-process layer. This will allow you to do a few things in here. Number one is it'll ask you what the trigger is. It's set to the main camera by default, whatever camera you added in there. You can keep that on. Next, we have to set up the layer. Now, the layer system is used for Unity to sort objects and other things that are being rendered. This is where you can tell which volumes or which post-processing this camera should use. Just because it has a post-process layer means it'll use basically any of the post-processing available to you if you keep it on like a default layer. By default, it's set to nothing. So what we have to do is we go back to our volume and we have to set a layer for the volume. So when you pull down here, you should have a few layers. I've added a post volume, post layer into my layer here. If you do not have one, if you're not starting with the side scroller project, you can add a layer. You could call it whatever you like. Just go to add layers, type whatever you like. And then when you go back to your volume and do that again, that layer will appear in this list here. Unity has a maximum amount of layers set to 31. That's all you can have, I believe. There's also sorting layers and tags, but we could talk about those on different days if you're interested. So once you have a layer, you're going to go and set your volume to be on the post layer. Then you're going to go back to your camera, and under the post-processing layer component, under layer, you're going to pick the same one. And if you try and pick default, Unity will give you a warning. Please don't pick everything in default. It's not a good idea. So that's why we create layers, keep things nice and simple and organized. If you are using the deferred rendering, you can set your anti-aliasing in here as well. So you could say what kind of anti-aliasing you want. So if you want to get rid of some of your jaggies, you could set that up in here. You have some different options for how to set up certain things here as well. So I believe the project by default is set to forward. You could set it to the deferred render pipeline or render if you like. And if you are interested in what those mean, I can talk about those as well. Okay, so now we should have everything set up for post to actually work. There's one other thing I haven't done yet, but I left it off on purpose because this also drives people crazy sometimes. So now we have it all set up. A lot of people miss a lot of these steps and they're like, my post isn't working. What the heck? So there's two more things that will prevent the post from working currently, and we'll take a look at what they are. But first, let's just add an effect. We're going to add ambient occlusion. We'll talk about what this is in a second. I'm just going to put up the intensity. And nothing has happened. My scene doesn't look any different. My camera scene doesn't look any different. The post is still not working for two reasons. Number one is the volume that you've created by default is actually set to not be global. So only the cameras that are inside this volume will accept this post-processing. So right now, let's just set it to global, and you'll see that the post gets turned on. I was kind of hoping it wouldn't do it because I thought I didn't have something set on. This little button wasn't on here. So if you do that and your post still doesn't turn on, most likely up in the editor view here, it may look okay in the game, but in the editor, you may not see your post. There's a little like two stacks of sheets and a little star on top here. This allows you to turn different things on and off for viewing in the editor. So you have to make sure that's on, otherwise you won't be able to see your post. I don't know why I turned on before. I think Unity just had a hiccup there. And we have now successfully added and set up post into our scene. So nothing crazy so far, but at least it works. So if you follow those steps, your post should at least work in your game. So let's talk about the different posts that is available to you, and then we'll go back and we're going to talk about volumes a little bit and how you can utilize those to get some different looks across your game. So the first thing we've added here is the ambient occlusion one. I'm a big fan of the ambient occlusion post-processing. Basically what it does is it takes any kind of crevice and intersection of like concave objects and adds a little bit of a fake shadow in there. So if we look at it from our game window, you'll see here it adds a little bit of a shadow into those ones. It's very nice. It adds like a weight to your scene. It really makes things like stand out and feel a little bit more 3D. It also helps things like sit on the ground and sit together nicely. So I quite like it. Some people don't like it, but I feel it helps the art just look a lot better right off the bat because it just adds some nice detail and gradients and stuff like that to there. So in there you have intensity. You could crank it up and down, make it look wild. There's different modes as well. You can kind of find out which ones you like. This one does much like thinner post. This one kind of does a little bit more broad. So pick the one that you like, and go from there. You can pick some thicknesses, how much it covers. You can also change the color, which is pretty cool. So if you wanted to go with something a bit more stylized, you can do something weird like that. And ambient only will turn off how it's overlaid on the scene as well. So this way you see it's kind of taking a little bit of the color of the objects it's on and the lighting. When you turn ambient only off, it just kind of becomes like the color itself as opposed to trying to blend in with the environment a little bit. So Anyways, that's ambient occlusion. Use it as you see fit if you like it. Next one we're going to go over is we're going to skip auto exposure just because it's not something you use a lot in side scrollers. But what auto exposure does is, you know, that effect where when you are inside somewhere really dark and you go outside and things are super bright for a couple seconds, and then your eyes, like your pupils adjust, and then everything kind of goes back to normal, and vice versa. If you're in a bright environment, you go in somewhere inside, everything's like super dark until your eyes kind of open up again. That's what auto exposure does. It helps to kind of mimic that effect and balance out some of the brightness and lighting in your game. Next is everyone's favorite is bloom. Bloom makes things a little glowy. So if you want to nuke your world, you can. So bloom is pretty fun. So the way bloom works, I forgot to explain this for ambient occlusion, but these are all post-process effects, which means they happen after your scene is already rendered. They're not taking place during your actual scene and gameplay. They're happening on every frame after that frame is rendered. So what ambient occlusion does is it actually takes the depth texture that is rendered. Unity and all game engines render basically a texture that signifies how far away all the objects are in that frame, and then it uses that to apply the darkness and blur on top of it. So you can imagine post-processing as Photoshop, right? It takes your frame, brings it into a post-processing little utility, and then applies image effects on top of your rendered frame. So what Bloom does is it finds every pixel that is above a certain value and then blurs it a certain amount and then overlays it back onto the original image. So intensity is how much to blur that image and how much to like push it out from the center. Threshold is the one that will set how bright a pixel has to be before it does this operation. So you see, as I bring it up higher, it's only going to select less and less pixels, the ones that are only above a certain brightness. So I like to typically keep this above 1 a little bit. My intensity is usually just at like 0.3 or, you know, maybe a little higher, depending what you want. But if you want it lower intensity and lower threshold, you can kind of get like a dreamy, you know, bloomy effect out of it. If you're trying to make like Twilight Princess, you know, they had this basically set to 0, just had everything kind of blooming a little bit. So kind of up to you what you want. You can play around with a lot of these settings. They kind of dictate how the blurring happens and the overlays kind of happen. But you can also, you know, have a lot of fun with, you know, picking some of the colors, right? You can actually make all your bloom like colorful a little bit to add a little, you know, fancy pants kind of feel to your game. Fast mode is if you're doing mobile as well, so you don't have to worry about that. The dirtiness texture is kind of cool. It also doesn't really make sense for a side scroller, but it's, if you imagine you're wearing a helmet or a visor of some kind, and there's dust or dirt on it, and when you know, light shines at you and it's bright, you'll see that dust because it's actually the light is hitting that stuff, and you know, you get to see it. I don't know if we have any. They used to provide a pretty cool texture here, but now they don't, it seems, which is very rude. Let's see what we could put on here. What's all these snowmen? Weird. So anyways, we'll add some stained glass in here, and then we can crank up the intensity. So you see here the you can kind of see a stained glass over the camera, and then as the bloom goes down, you won't be able to see it. So it's only one. You know, I'm playing Metroid Prime again, and Prime had that effect when you, if something bright happens, you could actually see like Samus's face a little bit because the glass becomes more reflective when certain things happen. So you kind of get that kind of effect too. But again, it doesn't really make sense for a side scroller, but it's there for you if you want it. Chromatic aberration basically splits your image into RG and B layers, and then allows you, and then splits them at the edges of the screen. It's just like a fun little film effect. You can use it for, like, you know, if you're tripping out, or if you just want, if your game is sci-fi, you know, sci-fi games do this a lot, make it look all fun and badass. Color grading is a lot of fun. This is like your art direction tool, basically. You can set what kind of ranges your game has. Usually you're on HDR these days. You can also pick tone mapping, which kind of dictates how your lighting and your colors work in your render frame. So none kind of just does the regular one. Neutral tries to chill everything out. ACS is a little bit more contrasty and tries to mimic some bit more of a realistic color. And you could customize it by doing some crazy graphs and things. And oops, right, if you really wanted to get super deep into tone mapping, but I usually like ACS. That's my favorite one, but the game we're making right now is a bit more cartoony, so we're using like a neutral. None I usually don't like because it handles the brightness like pretty crazy, so depends on what you kind of want. But then you can also play around with the temperature of your game, your tint, right? You could even do post exposure, right? So you could do something where you crank this and then crank the contrast, right? You could have some fun getting some pretty cool looks out of your game, right? You could desaturate it, you can hue shift it, right? So lots of fun, kind of again art direction-y kind of stuff you could do with the color grading um, effect. You can even do these little guys. These guys are kind of great. You can affect like the lift, the gamma in different ways, and you can get like a cool kind of mix of colors going on depending on your brightness, your darkness, and that kind of stuff. This is kind of what movies will do when they want to set like a specific style to a movie. So if you're watching like a David Fincher movie, he has his own kind of like color grading that he does on his films to make it look like a certain way, and it's just it's why movies look like the way they look and they don't look like real life when they're shot with just a camera. So anyway, so that's color grading. Next we will have depth of field, which is exactly what it sounds like. It blurs out things based on distance. So I'm going to lower my aperture here to blur things out a little bit. And I'm going to pick my distance. The built-in default depth of field is not great. It's much better in like URP and HDRP, obviously. But you get what you get kind of with it. So anyways, depth of field is awesome. It does look very pretty. I very much like it. It's a really nice way of getting your foreground and background elements to really stand out. Right? Everything kind of blurs out in the background. It really feels like it's behind the player. It's a nice way to separate things in and out of the scene. Yeah, Fight Club in 7. Yeah, exactly. Yeah, for sure. This is just the Sphere Man side scroller there. And yeah, that's right. There is a bad thing about depth of field, though. I will tell you. So with depth of field, it is yeah. So depth of field is the one that blurs out the background. It's also a post effect, so it does the blurring after the frame is rendered, and it does something that is not very good for your scene, which is it doesn't work very nicely with transparent objects because it happens after the fact. Transparent objects are not added to the depth texture that is rendered. They're just not, they're too complicated to try and calculate into a texture space. They're hard to visualize with just like colors of a flat image. So they don't get included into that. And so I'll show you what that means. So I'm going to create just a plane here. And I'm going to throw a material on here. It's my cloud mounted one. Okay, so you see here that the cloud that I just added on here is looks pretty good down here, but when it starts going over areas that are being blurred out by the depth of field, it is also being blurred out. And this is not a good look because, well, it's over here. It's it's in front of Sphere Man. It's close to the camera, but it's still being blurred out like it's in the background, like it's far away. Again, because it is not actually being added to the depth texture, which is unfortunate, but it's a very hard thing for engines to do. So you're going to get some really weird kind of effects and looks if you try and use transparent objects. This is why in some games you might notice that like characters' hair, if there's a cinematic, at the edges it might look really blurry if there's a depth of field on it or things like that. So any like particle effects you have, once they get over into your depth of field area, they will blur out and they will look not super great. The one solution you do have for this is to not use transparent objects, which I know isn't great for some things, but if you're doing a very cartoony game, that will work. In your shader, let's use just our standard shader here. So if we have transparent, we'll use the transparent object obviously here, and it'll look bad. But what you can do is if you go to cutout works because cutout treats that transparency like geometry. It actually just cuts out very hard values and then treats it like geometry, which is then added to the depth buffer. The bad thing about cutout is it only deals in absolutes. It's like a Sith. It's either 1 or 0, and that's it. It can't do things that are partially see-through. It's literally a cutout, like you cut it out with scissors. If you actually look up close to it, it's no longer a transparent texture. It's like actually like a geometry cutout, very very like smoothly. So you can't get something transparent. So if I try and change the transparency on this, eventually it'll just disappear. So again, not great for all aspects, but it's a way to fight the depth of field and whatnot. So those are options for you. You know the pros, you know the cons. How you deal with those is up to you, whether that's still valuable to you or not. You can use a multiple camera system because we are on the built-in render pipeline. We did this for Lost Orbit. We rendered basically everything behind the player on one camera. We rendered it first, and it did all the posts on it first. And then we rendered the foreground or the gameplay layer second, and then composite on top of that. And then did its own post-process on that without any depth of field. So that way we still got a blurry background without dealing with any of the things like that. So you can do that. It increases performance, but I can't show you how to do some of that stuff because it can be quite handy. So yes, let's go back to our volume. And what is next? We got grain. Some of this stuff is probably fairly self-explanatory. Grain is some grain onto your scene. That's always refresh here. So I guess that doesn't work in scene view. So grain adds, it's maybe hard to see, I don't know, but like a little bit of noise in there. It kind of breaks up things. It's used in a lot of games to break up like bad banding on textures or just to add a little, je ne sais quoi to your levels here. You can obviously, up the size and make it look super gross, but it's there for you if you're trying to make your game look a little fuzzy or, have a little, texture to it overall. Lens distortion's the one if you want to really hurt your player and make them throw up a little. Wow. This is like a fisheye kind of effect. Right? You can decide, which direction you want it to happen in. You can even change where it's centered. And you can change the scale of it. You see it's actually rendering the frame, and then the pixels at the edge, it's just extending out forever because it doesn't know what else is going to be out there, but it needs some sort of color to push that. So this is, used if you want to, make the player feel like they're feeling a little gross or something. Or, like they're tripping out on something or whatever. You can have some fun with that. It's usually a little nauseating, but, can be used for things. Next, we have motion blur, pretty self-explanatory. Adds a little blur to anything that's moving. Screen space reflections, which is one of my other favorites as well. Reflections are very expensive in rendering, so real reflections are not something you could typically do very well. You could do cube maps, which are an approximation. You could do planar reflections, which are real reflections, but they're very resource intensive. You could do screen space, which basically takes it samples all the pixels of your screen, finds out what's reflective, and tries to mirror what's around it in the rendered frame, which is pretty great. So I'll show you how this works. We're going to turn the quality to overkill just so you can kind of see what's going on. Now you can see a little bit of change here right when I turn it on. You get a little bit of extra color, some bouncy lighting and stuff like that, and that's cool. But what actually needs to happen is any material that you want to reflect, that's all dictated with the smoothness. So the smoother the surface, the more reflections it'll get. So if you see here, if I crank this to 100, over on the right hand side, you can see a little bit of a line here in the shadow of this guy. The reason we can't also see it very well is this texture is very bright and our scene is very bright. So if I lower this a little darker, you'll be able to see some reflections. Now again, because it's screen space, it's not real reflections. It's trying to figure out what's actually happening on a post-processing kind of level. So you will get a lot of weird streaking and things like that, but it still looks pretty cool overall. So it still has a nice general look to things. Obviously this is like, very extreme. All right, you can chill it out a little bit. You can also turn everything metallic. Right, which then will basically only take lighting from the reflections and stuff like that. So up to you how you want to use it. I quite like it. You get a nice look on things. Obviously, if it's something that's supposed to be reflective, like plastics and metals, but it adds a nice little, little feeling to your game there for reflections and things if you want to use it. So it's there for you. It can make your game look very, high res and fancy pretty quickly. So. And the last one is the vignette, which just adds a little edge around your screen. So if you just want a little darkness around there, you can also use this for like, if you're taking damage or your player's dying, you can do this kind of thing, right? Now, any of these post-process effects that I've shown you here, are fully editable and animatable through code at runtime. So, this smoothness you can animate in, or the intensity, you can animate the lens distortion, the depth of field, whatever you like. Those are all things that can be set while the player is playing. Studio Bones has a bad habit of fisheye lens. Some people love it, right? Some people love that effect, and that's fine, whatever people like. But anyways, so that's all the posts that's available to you. There's not, a tremendous amount of it to go through, but the combinations you have, you can do something pretty awesome. Now, I've told you before that you're not allowed to really get stuff off the Unity Asset Store in terms of like code or assets or mechanics and that kind of stuff. I don't expect any of you to be able to program your own post-process effects. In HURP and HDRP, you can actually use Shader Graph to create your own post, but I don't think you could do that in built-in, but I could be wrong. But if there is an effect that you really like on the asset store, if it's free, you can pick it up. I don't recommend spending money on this class, but if you already own a particular post-process effect and would like to use it, you can if you like. So if you have like an outline shader or something else. What is HDRP? It's the high definition render pipeline. It's the one we use for Rocket Rumble. It allows you to do like lots of fancy pants stuff. Really cool VFX, lots of cool reflections, volumetric fog, really stuff we didn't need for Rocket Rumble whatsoever, and it just actually ended up causing us a lot of pain when we had to switch over to the Nintendo Switch, because the Nintendo Switch does not support HDRP. So we had to go back down to URP for that one. So Unity doesn't support the Nintendo Switch. Unity has to support all the consoles. They don't just work right off the bat. So if they don't build in the code for it to work with that, Nintendo Switch is not a very strong console in terms of hardware, so it can't do a lot of the fancy stuff right off the bat. So it needed to get optimized for that render pipeline, and they promised they were going to do it. That's why we used it, because they're like, yeah, it's going to definitely work on the Switch eventually. And then near the end of our production, they're like, nah, we were kidding. We're not actually going to do it. So anyways, so that's the post process for the game. Oh, no, it's okay. You can ask a question if you like, Lexi. What's up? All the stuff that I just showed you there, that's called post-processing, all the fun effects. So like the bloom and the screen space reflections, this vignette, all of that is called post-processing. Yeah, all this stuff. It's just like fun little effects on top of your scene that can make your game look a little bit different and or nicer. Or worse if you do something super gross. But so there's one more thing I'd like to talk about for post-processing, and that's the actual volumes here. So if we go back and we turn global off, it's just going to turn off all of our post-processing here. And what that means is when it's not global, it means only cameras that are inside this volume will get this post-processing. So let's make this a little bigger. And when I move this around, if I put this into my camera, you see here, it's going to turn that that post-processing back on. So we could do a lot of fun stuff with this. We can set up little volumes here. Let's do. Right, so I made a little cave section here for my game. Oh, actually, there is something else I forgot to talk about, but we'll get there when we get to the cave. There's my little dot here. There we go. So what we could do here is we have one post-process for the outside area, and then I could set up another post-processing volume for the inside of my cave here. And so what will happen is when the camera enters that part of the level, it will look different. So we could set up some different colors and other things for the game based on that. All right, so now we have two different volumes. In here, I'm going to take my volume. I'm going to find where it is in my project, and I'm going to duplicate it. And I'm going to add it in here. Now, the one stipulation, if you want these to transition nicely from one to the other, is you have to use the same post on all your volumes. So if I go in here and I turn on lens distortion, it won't animate into my different lens distortion. It'll just like turn it right on. So let's see what that looks like. So if we go over here, let's get the game window up here. Actually, I'm going to move my scene over to a tiny little scene over here so you guys can see. So now when we move our Sphere Man and our camera, when we go over here, you see the lens, the lens effect just pops right on. Now that's happening for two different reasons. Number one is this uses the lens effect and this one does not. So if we go over here and we turn this to 0, and then we go over here and we turn this to, whatever, -60. Now, when I transition between these two, they will have the opportunity to blend. Now, they still won't do it. You see here, they still do that. It's because we don't actually have any blending set up on our volumes. So if we select our volumes here, in the inspector, there's a blend distance size. And when you crank this up a little bit, it will add a little double kind of collision on top of this to show you where the blending is going to happen. So now if we take our Sphere Man, you see here, it actually animates between those two things. Right, so we can do that with some other stuff here. Let's do color. Let's do saturation. Let's make it black and white in here and regular in here. So now when we go and we move in, it will slowly transition into our black and white value. And the bigger we make our blend distances, the longer that will take place over. So depends on how quick or slow you want it to be. Whoa. So that's a very powerful effect you have there to be able to change things based on location and stuff like that. So I wanted to do this for my cave here. So for two things I don't want a gigantic blend distance because the cave is kind of supposed to happen pretty quickly there. And I don't want all this crazy saturation. Well, maybe saturation a little bit. Yeah, we're using the same scene, so it makes sense that they would look the same. And then I'm going to turn off this fisheye. Go again. Yeah, let's just turn this to 0. And maybe in the cave, so let's move our camera and our person into my cave here. Let's see what we want our cave to look like. So maybe we want it to be, yeah, a little desaturated. Maybe we want it to be a little bit more contrasty, right? Or something like that. Yeah, maybe we want to do some color grading. So maybe we want our cave to feel a little bit more red or colder or something like that. I don't know which one I want. There, that's our color selection for there. So now when the player enters the cave, it's going to start getting funky. And then when they leave, it's going to turn off. So what we're going to need to do is we're going to need to make another outside volume, excuse me, on the other side. So that way when the player then exits, it'll transition back out. Cool. Now, one thing I forgot to tell you, because I don't have notes and I'm just winging this, is with the bloom. Your bloom actually has another value that kind of dictates how it works. So if we go into here and we have our bloom, which I did kind of talk about, but I forgot to show you an example, I suppose. We have our threshold. So if I set my threshold to 1 in here and my intensity to be a little higher, oh, whoops, that's the wrong one. Something like that. Basically, it's looking for pixels that are over a 1 brightness in the scene. And we actually have to set those pixels to be that high. So what we actually can do is, let's say on my lava here, in my emissive value, you could do, I guess, built-in just has this one, right? Yeah. On the bottom here, there's an intensity slider. And right now it's just set to 1.0152. But as I crank this up, you'll see it starts blooming out more in my scene because the closer I get to my threshold value from my that's on my bloom setting, now it's at 2. So if I go back to my bloom here and I start putting up this threshold value, it'll start blooming less. So that they kind of work in tandem, right? You need to push your pixels over 1, and then you need to set your bloom threshold to be a certain level as well. So there we go. So that's our quick little overview of post-processing. The things people typically get caught up on in this class is just setting up the post, because it is a bit of a complicated process of doing the volumes, the layers, adding all the layers properly, turning off or putting on global or turning it on, whichever one you want to do, and just setting that up. And then a lot of times people just don't know what the different post does. So hopefully that's an okay overview for you to get started with post if you weren't familiar with it, and hopefully troubleshoot some stuff if you are having any issues. So that'll be it for post, and then we're going to do lighting as well. And I'm going to do just a few very minimal things on lighting. Oh, hold on.